class last time was we actually developed the law of sines. Now, I believe that I put sine A over little a, sine B over little b. I'm going to make a change there because I think it will be easier to work with. When I say sine A over A, you're like, wait, which A's on top and which A's on bottom? Yeah. What we're going to do, you remember those Greek letters I showed you the first day of this? I don't even know what, I don't even know. All right. We're going to use alpha for A, angles, beta for angle B, and we're going to, You can, you just practice, but you can. So the way I'm going to call this, I'm going to use the law of sines as the sine of alpha over A equals the sine of beta over B equals the sine of gamma over C. Remember, angles on top, sides on bottom. All right, we are going to draw a triangle, and we're going to solve that triangle. Let's look at these given criteria. We're told that we've got triangle ABC and that the measure of angle B is 130 degrees. If you have an angle that's 130 degrees, don't draw an acute triangle. Because 130 degrees is what kind of angle? Obtuse. Draw a danged obtuse angle. Okay? So we're going to do this. Now I need you to know, Sparks uses A, B, and C, big A, B, and C for the angles. We're going to use alpha, beta, gamma, okay? B, what am I going to use for that? Beta. Where does beta have to go? Dadgum, it's got to go right here. There's angle beta, that's 130 degrees. Now, it doesn't matter where alpha and gamma are. It doesn't matter which. I'm just going to put them there. The sides are little a, b, and c. Which side is here? Angle beta, its opposite side is B. Angle gamma, its opposite side is C. Angle alpha, its opposite side is A. The side corresponds, is across from that angle. Yeah. All right, we are told side C is 11. We are told side B is 15. We cannot use the Pythagorean theorem because not a right triangle. I cannot use a trig ratio because it's not a right triangle. So this is an oblique triangle. There's not a right angle in it. I can use law of sines. Now, what do you have to know in order to do the law of sines? And I'm going to have you write this in a little bit, just not right now. You have to know an angle and the side opposite it, and one other piece. Okay, so listen again. To do law of sines, you have to know an angle and its opposite side, and one other thing. Okay? Do we know an angle and its opposite side? Yes. Which one? So I'm going to have to use sine of beta over b, because I know both pieces of that, right? Now, the other fraction I use, I just have to know one part. Well, what if okay, if I know side C, then what can I find? Angle gamma. So here's what I'm going to do. I'm going to write sine of gamma over C. You're just going to do a proportion. You're just going to take any two of these three fractions, set them equal to each other, and by golly, we're going to solve that sucker. Let's put stuff in and let's see what we got. What is beta? So you've got the sine of 130 degrees over 15. equals the sine of gamma. Do I know the measure of angle gamma? Nope. Over. What's my unknown? Gamma. So I'm going after angle gamma. What I would do, to be honest, just to make it as easy as possible, I would just cross multiply. So let's cross multiply. How do I get sine gamma by itself? Divide by 15. So I've got sine gamma equals 11 sine of 130 degrees divided by 15. Now, somebody said, I don't know if it was Maribel, somebody said, we'll just multiply both sides by 11, and that would have been just fine. You'd have gotten this right here. How do I get gamma by itself? Sine inverse. So, way to go. Sine inverse. So, instead of writing all this again, let's just do this. Let's just put sine inverse. Sine inverse. Now, folks, you're just going to plug this into your calculator. Please use alpha y equals to use your fraction function to put this in as a fraction. Make sure you're in degree mode. So what we are left with here is gamma, and what I was seeing on calculators was 34.178. You give me that answer, I count off degrees. Okay, let's see what else we got to find. 34.178 degrees is right here. Now let me make a comment before we go any farther. If you decide that you want to use angle gamma in later work, please know that this is not exact, right? Do you know how to use the store function on your calculator? Store? Do you know how to do store on your calculator? Recording. Huh. I think I forgot to record this piece right here. Can I say it again? Look at the red. We cross multiplied from the law of sines. We used capital A because that's where we put angle A. That's where we stored angle alpha. Divide both sides by sine 130. Run that on your calculator, but remember you've got that stored, so use your store function, or your alpha character A. Are you getting that number? I'm hearing a uh-huh, and uh-uh. Last page. Do you remember I told you a little bit ago, don't write this down because we'll do it later? In order to apply the law of sines, what combination of information in a triangle do you have to know? You have to know an angle.
And its side length.
And its side. And one other piece. And something else. That's right. You have to know an angle and its side and something else. Do you remember in geometry? How many of you have just kind of put geometry out of your mind?
I choose to forget that part.
Choose to forget. Okay. Do you remember side, side, side triangle? Let's talk about those for just a minute. You don't have to draw this. Let's just go down here and think for a minute. You had side, side, side triangles. Well, I don't want to do it that way because that implies that they're all the same length, doesn't it? If you knew this, that would be a side, side, side triangle, right? Can you use law of sines if you have a triangle and you know all three sides? I don't know an angle. I cannot use law of sines on a side, side, side triangle because I don't know an angle. Okay, let's look. What if I know this, and this, and this? Then what is the setup with the letters S and A? Right. Can I use law of sines on a side angle side triangle?
No. You have an angle, but you don't have its side.
Oh. I know an angle, but I don't know its opposite side. What's that? Angle, side, angle. So no on law of sines, no on law of sines. Can I use law of sines on this?
No.
Well, you can figure it out because you have to be able to do 280 minus that and get that angle that she drops.
Good brain.
I can use law of sines here because I know enough to find this angle. So I can use law of sines here. Now, there is, where I want to be, snap, where to go. What's that called with S's and A's?
SSA?
We're not going to go the other way, okay? We call this a side-side angle, right? Now, in my class, we call that the dirty triangle.
One side.
Side, side, well, snap. Angle, angle. Did I do angle, angle, side right up there? How about this? Nope, nope, nope. Is that better? Side, side angle? Yeah. I called that, that's what I meant. We call that in my class a dirty triangle. Because if you reverse the SSA, don't be smart aleck. It's a word we don't say, right? Could you use law of sines? Sure could. Sure could. Now, in geometry, you were told you can't do those. You can now. The reason you couldn't do them in geometry was if you are given a side, and an angle, but you weren't given the triangle, you weren't already told what it looks like, that setup might not even make a triangle at all. It might make one triangle, but it might make two. We'll deal with that another time. But that's why you were not ever able to do those in geometry, because you have to do law of sines. So, let's go back up here. What combinations of information within a triangle would not allow you to use law of sines?
Anything that doesn't give us the above.
You could not do side, 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 or side, angle, side. So, ladies and gentlemen, you get to use law of cosines. Law of cosines is not hard. Now, it looks a little uckier than law of sines. I could derive this formula, show you where it all comes from. It'll take about that long. And if you want to know, you come see me and I'll work through it with you, okay? Law of cosines can be written in three different ways. A squared equals b squared plus c squared minus 2bc cosine alpha.
Along with this class.
It does look very similar to the Pythagorean theorem. In fact, the Pythagorean theorem is a special case of the law of cosines. Oh, you didn't know that, did you? B squared
So we're going to have a panic attack.
equals a squared plus c squared minus 2ac cosine beta.
It's different. Wait.
I got one more.
Yeah.
Look at the pattern. C squared, all right, hang on. C squared equals A squared plus B squared.
Minus 2.
That's it. That's it. All right. Do you notice that the angle here and the side out here match? Pay attention to that. The angle here and the side out here would be opposite each other. Okay? All right. We're going to use law of cosines. You're going to have like half hour, daggone, to take a nap? Really?
That's spiritually.
All right. Solve this triangle. What are you given in that first triangle? Side, 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 right?
How evil.
Side, side, side. So we're going to draw a triangle. Do I expect you to draw a picture? Yes, I do. Do not draw a right triangle here. Draw a picture. Don't put right here the shortest side, okay? So I'm going to put right here, I'm going to put B equals 4, C equals 9, and A equals 6. Why can't I use law of sines?
No angles.
Because I don't know any angles. So you think, well, crap, which of those three law of cosines do I use? You need to pick what angle do you want to go after first. Now, I'll use it twice. I'm going to use law of cosines once to find an angle, once to find another angle. But once I know two, then I can do 180 minus and get the third one. Now, hey, what angle is right here? Beta. Thank you. What angle is right here? Alpha
Now, yeah.
and gamma. Let's find angle alpha, just because we're going to start in alphabetical order. So let's use the equation that's got alpha in it. Now, the way that's going to work, A squared equals B squared plus C squared minus 2BC cosine alpha. We're going to plug in what we know. 6 squared equals 4 squared plus 9 squared minus 2 times 4 times 9 times the cosine of alpha. Are you okay? Good. 36 equals 16 plus 81 minus 72 cosine alpha. When you get that far, please stop. Hey, Jackie. Right here is where you're going to get hung. You pay attention to me and you tell me what mistake I make. Because the mistake I make is the mistake I see every darn year in pre-cal. You may already know. I am going to make a mistake. Have I made a mistake yet? Okay. I was going to say I better not have. This and this are not like terms. You cannot combine them. Every darn year, people want to do that. That's my mistake. So, you can work with me from here on. Subtract 97 from both sides. There you go. And if I'm not mistaken, I think that's negative 61. No, you check. You with me? How do I get cosine alpha by itself? So I've got cosine alpha equals 61 over 72. What now?
The inverse of cosine.
Aha! Cosine inverse. Cosine inverse. That's going to figure what alpha is. I get is that right?
Yes.
Now, I don't know if I'm going to have to use that later or not. Store it. So store that, since we're using alpha, store that in A. That way, if we need it, we've got it. And I would suggest when you store, make yourself a little note to remind you where you stored it. Because you'd be getting to it and you'd think, crap, I don't remember where I put that. All right, so you got that one, right? Now I'm going to tell you something else that you're going to want to do, and you're going to be a little mad that you can't. I know angle alpha now, right? Now I use law of sines. No, I can't. It goes back to that dirty triangle thing. Once you start with law of cosines, you have to stay with law of cosines because you could get a wrong angle. Just trust me on that one right now, okay? So, we know what angle alpha is. Pick one of the other angles to find. Beta. So, use the equation up here that's got beta in it. B squared equals A squared plus C squared minus 2AC cosine beta. B squared equals A squared plus C squared minus 2 times A times C. Where'd you go? Two times A times C times the cosine of beta. Now I'm just working it. You're working it. Have a look up here and tell me if I screw it up. Is that 117? What's that, negative 101? Tell me if you got that or if I missed. I might need that. So where should I store that? Store that in B. Better to store it and not need it than to need it and not have it. What's the last thing I need? Need angle, gamma. You bet. Do A plus B and then 180 minus answer. A plus B and then 180 minus answer. And that will tell you what your angle gamma is. What's gamma? 127.169 is what Spark says. You have questions?
Yeah. On our homework,
Go.
do you want
Yeah.
us to like fill it in on the little
You do not
triangle?
have to fill it in on the triangle if you don't want to. No, you do not have to. What I will kick your tail on is putting your degree symbol. Put your degree symbol. We got one more to try, right? This one's not a side, side, side. This was a something, something, something else. I'm going to draw it over here. Alpha, beta, gamma, little a, little b, little c. Now that's not really to scale either, is it? Because that's a longer side than C, but oh well. And B is 65 degrees. Use S's and A's and name this. What is it? It's a side angle side. Good. Can I use law of sines? What would I have to know to use law of sines?
Yeah, B.
I need to know side B, or I'd need to know one of the other angles. I only have one of those options that I can even use right now. Remember how there are three, the law of cosines comes in three different formulas? There's only one of them I can use this time. Which one? Why the one that starts at b squared equals? Because I only know A and C, and I know angle B, beta. So we're going to go at it this way. B squared equals A squared plus C squared minus 2AC cosine of beta. You don't have to write the formula down. You can just start putting in the numbers. That's not a problem. B squared equals A squared plus C squared minus 2AC cosine of 65 degrees. Now you like it when you get these. What's that, 193 minus, is that 206? No. That's what, 494 does, what is that? 168. Put that sucker in your calculator. Put that in your calculator right like that. $122?
0.001.
Is that side B 122? You got to square root it because that's B squared. So do square root of answer. Oops. B is approximately 11.045. What do I want you to do with that number? Store it. Please store it. I would suggest that you store it in B, since it's side B. So now I know this. I know all the sides, right? And I know one angle. I cannot go back to law of cosines, though, because I can screw myself up. Well, I've got to go to law of cosines one more time. Which one of those angles do you want to find, alpha or gamma? Gamma, fine. Now, if we're going to find gamma, the equation that's got gamma in it is now you start working it, I'll work it here, and we'll see that we get the same thing, okay? Do a heads up with me real quick. Look right there and right there. What's that? It's what you just stored, isn't it? That 11 point something?
That is alpha B.
I do not have a big B in my picture, do I?
That is beta.
That B just means that's where I stored this. Okay? So you're going to do 12 squared plus B squared and get that number. 2 times 12 times that B and get that number. I'm going to tell you what the answer is, and if you're having trouble, holler at me and we'll work on it. What am I looking for? Gamma? If you quit using yellow.